Okay, so we are starting today real numbers part 5. So as we have discussed some formulas, so now we will do the question on the formula HCF into LCM is equal to product of the numbers. That question number 2 we did already. Now we will do question number 3. And here we have to find the HCF and LCM of 3 numbers. Before that it was 2 numbers. Now we have to find the HCF and LCM both, but the method is prime factorization method. So we can take first question. We have 12. First number is 12. So you can find the factors of 12. 2 6 are 12. Prime
2
factors
into
of
2 into
12.
3.
2, yes. So factors of 12 are 2 into 2 into 3. Prime factorization. The method is what? Prime factorization. So that's why we are doing the prime factors. And then we have to find the factors of 15. So it is divisible by 3 only. 3 5 is 15. So factors of 15, 3 into 5. Then 21,
7
factors
3s
of 21.
7
21 is
into
divisible by
3
yes,
7s
3.
are
3 7 are
7.
21. So factors of 21 are 3 into 7. 3 into 7. So 3 5 7. If you see that you can do by the previous way that you were doing in previous classes. 3 is common here. Or you can say what is the common number here? 3. And what is the minimum power of 3 is 1. So therefore HCF is 3. Okay. Then LCM, for finding LCM, first you can write 2 into 2, 2 raised to power 2. Then 3 is common. So the number which is common in all the terms will be written once. And rest of the number will be multiplied to get LCM. So 2
Sir,
2
is
is
that
4,
root 2?
4 3
Sir, is that root 2?
is 2 square.
Sorry, sir. Yeah, 2 square. Okay.
So 5 7 5 is 35. 35 into 12 will be 420. So HCF is 3 and LCM is 420. Like this, we can do question number 3. Now we are taking question number 3. Okay. So in question number 3, again same procedure. To follow the same procedure, find the factors of 8. Now we will write the factors in powers. So prime factors of 8 are 2 raised to power 3. 2 to the 4, 2 to the 3. Third question, we are doing third question. Okay. And prime factors of 9 is 3 raised to power 2 3 3 is 9.
Square.
Yeah.
5
Prime factors of 5 raised to power 2. Okay. So LCM, as I told you, HCF. HCF means highest common factor. The number which is common, first check, is there any number which is common? No. So therefore HCF is 1. And in LCM, we will take 2 raised to power 3 into 3 raised to power 2 and 5 raised to power 2. So 8 into 9 into 25. Multiply them, you will get 1800. So now we will do an extra question. If two positive integers, there are two positive integers p and q, which are composite numbers, obviously, because they have written in the form of a square b cube. P is written in the form of a square b cube, where a b are prime numbers. So that means it is a composite number and its factors are a square b cube. And q is a composite number, its factors are a cube b. We have to verify. So obviously, for verifying, first we will find LCM and HCF, and then we will verify it. So first find LCM or HCF, anything you can find first. So in LCM, I told you that we have to take the maximum power. A square, a cube, a is common, but the highest power of a is cube, so a cube. B is common, highest power of b is b cube. So LCM will be a cube, b cube. And in HCF, we are taking the minimum power of the common number. So common is a, and its minimum power is a square, and b is common, and minimum power of b is b, 1 power. So this will be the HCF and LCM. Understood? So as I told you, in LCM we are taking the maximum power, and in HCF we are taking the minimum power of common factor. And in LCM only minimum power of common factor is not enough, into others. For your means, don't forget that only if you will take only common, then it will not be an LCM. So rest of the numbers, if C is also there, you have to write C also. So here only the minimum power of common factors only we will take. So now we have to verify. So LCM of the numbers P, Q into HCF of these numbers.
Sir, a power 5 b cube.
Yes. So we have to write a cube, b cube, multiply with a square b. So a raised to power 5 and b raised to power 4, because powers will be added in multiplication. Okay. Now we have to find the product of the numbers. Their product means product of numbers, given numbers, that is p into q. What is the value of p? Is equal to a square b cube multiply with q. Q is a cube b. So 3 plus 2, a raised to power 5 and b raised to power 4. So you can see both are equal. Therefore, LCM into HCF is equal to product of the numbers. It is verified. So sometimes instead of giving some numbers, they can ask like this. Okay. So this is the question number 4, which is based on the formula. We can find by using the formula also. Question number 4. So we have given the HCF of these two numbers. Here two numbers are 306 and 657. So its HCF is equal to 9. The question number 4 we are doing. And its LCM of these two numbers is given as, not given. We have to find out the LCM. You have to find out the LCM of these two numbers. So as you know, we have the formula HCF into LCM. Here HCF into LCM will be equal to the product of numbers, means 306 into 657. But HCF we know we have to find the LCM, therefore we can write the LCM of 306 and 657 will be equal to 306 into 657 divided by HCF. This HCF will come here. It will divide the product. Okay. So 657 and HCF is 9. So 306 into 657 divided by 9. So in order to save your time in dividing, I will write the answer. You can check by dividing. Okay. 22,338 will be the answer. So sometimes HCF is given, you have to find LCM. Sometimes HCF, LCM both are given and one number is given, we have to find the other number. So by using this formula, we can make different types of questions. Question number 5 is different from all other questions that we will discuss at last. First, we will do question number 6 and 7. Then we will come back to question number 5. Okay. So question number 6. Explain why they are composite numbers. It is based on the concept of composite number that I told you. So we have to show that they are composite numbers. So how we will show? We will write first. We have given 7 into 11. This is question number 6. 7 into 11 into 13 plus 13. So how we will show composite number? Any composite number which is having the two factors. If it is divisible by two numbers or more, two or more numbers, then it is a composite number. So if we are able to write this number in terms of the product of two numbers, then it is composite number. So we will try to write, we can take the common term, 13 is common. When you take out 13 common, what will be left inside? 7 into 11, 77 plus
77
1.
plus 1. Yes.
Yes, so it will become 13 into 78. Correct? So when it
Yes,
is
sir,
written in the form of two factors, therefore it is a composite number. Therefore, it is a composite number. It is a composite number. Okay. Similarly, second question also, same way we can write the second number is what? 7 into 6 into 5 into 4 into 5 into 4 into 3 into 2 into 1 plus 5. So similarly, we can take 5 common. You will take 5 common, so 5 into 7 into 6 into 4 into 3 into 2 plus 1
1.
plus 5 is common. So obviously this will give one number. So it is written in the form of product of two numbers. So if you will leave here also, no problem. You can say that here it is proved that it is a composite number, because it is the product of two numbers other than one. So it is a composite number. So like this, it's very simple. Yeah, whatever it is coming. So you can
5
write,
into
yes, 7. You can multiply and you can write the number 7 into 6 into 4 into 3 into 2. So 1009. Huh? 1009 will come here. Okay, got it?
yes, sir.
Now the
Clear.
last question. This question is the word problem. So there are many word problems which are based on HCF and LCM. We have to recognize whether this problem is on LCM or HCF. So here there is a circular path. Here there is a circular path around a sports field. Sonia takes 18 minutes to drive one round. 18 minutes to drive to take one round. Okay. And Ravi takes 12 minutes. Sonia takes 18 minutes and Ravi takes 12 minutes. Okay.
Okay,
So suppose they start at the same point. Means Ravi and Sonia, they are starting point. Let's say it is a starting point. So they are moving like this. So after 12 minutes, Ravi will come back. And but what is the name? Sonia. Sonia will come back after 18 minutes. 3 minutes later
yes, sir. It
on
will
the
take
same.
time. Yes,
So
sir.
how many minutes will they meet again at the starting point? When they will start, they will not meet at the starting point in one round.
Sir,
But
LCM of
when
18 and 12.
yes, so we have to find in these case we have to find the LCM of 18 and 12. So we will find the factors of 18. So factors of 18 are 2 into 3 into 3, 9 to the 18. And factors of 12 are 2
6
into 2, 2 raised to power 2
into
into
3.
3. Okay.
Yes.
So we will find the LCM of 18 and 12 will be equal to, first we will take the common term. 2 is common and the maximum power of 2 is 2. Then 3 is common and it is one time only. Then 1 3 is left. So write one more 3. So 2 to the 4, 3 to the 9, 4 9 is the 36. So after Sonia and Ravi, therefore, will meet
36.
Sonia, yeah, and Ravi,
36 minutes.
Yes.
yes, will meet again
Again
at
after
the starting point. We'll meet again at the starting point. At the starting point after
36 minutes.
36 minutes. Okay, got it?
Sir, we have
Yes,
to
sir.
join again after 36 minutes.
No array.
Recording this. इसको पहले, yeah, now we'll see question number 5. Here we try to understand whether 6 raised to power n, 6 raised to power n means 6 raised to power n. N can be 1, 2, 3, any number. N is any natural number. 1, 2,000, 10,000, lakh, 10 lakh can end with the digit 0. क्या ये नंबर zeros पर end होगा कि नहीं होगा? तो अगर कोई नंबर, if a number ends with 0, so its prime factors will be, if a number is ending with 0, suppose 20, so you can write 5 into 2 into 2. Okay, so any number which is ending with 0, it must have 5 as a prime factor. One of its prime factor must be 5. Correct? Correct?
Yes,
So,
sir.
but here if you see 6, so what are the factors of 6? 3 into 2. Whatever the power will come, 10,000, like any power you can put, but the factors will be 3 and 2 only. So when 5 is not the factor, that means it will never end with the digit 0. That you have to explain only. In these type of questions, you have to just explain that the prime, a number which you will write like this. A number which ends with 0, with digit 0, must have 5 as its prime factor.
Factor. Yes, sir.
And that means one of the prime factor must be 5. But 6 raised to power n can be written as 3 into 2. That is 6 raised to power n can have prime factors as 3 and 2 only. It does not contain 5 as a prime factor. Therefore, 6 raised to power n can never end with the digit 0. It will not end with the digit 0. Okay, got it?